Today our topic is metals, non-metals, and metalloids. Let us define what are metals, non-metals, and then metalloids. If you define metals, so metals are the elements which normally lose the electrons. So basically, they tend to tends to lose electrons. So once you lose electrons, you get positive charge. Losing electron gives you the positive charge. Okay, so basically these are the elements in periodic table which have the tendency to lose the electrons, and when they lose electron, they get positive charge. Now you have non-metals. Basically, non-metals are the elements which tends to gain electrons, right? So basically they gain electrons. So now because they are gaining electrons, they will get negative charge. Because you know that electrons are negatively charged, so whenever they gain electron, they get negative charge, right? Okay, now if I want to know the basic difference between these two in form of any example, so I have sodium metal, right? So because it has 11 electron in its as a whole, so it in its valence shell it has only one electron. So mostly it has the tendency to lose electron. So whenever sodium lose electron, if it lose one electron, it will get one positive charge, and this is the electron it lost, right? Similarly, if you have magnesium metal, magnesium have 12 electrons, of course, two electron in its valence shell, so it loses two electrons. So losing two electrons, it gets plus two charge, and these are the two electrons, right? Okay, now you have another element. For example, you have chlorine. It has 7 electrons. So to complete its octet, it has tendency to gain electrons. So it electron will be added in its valence shell. So whenever electron will be added, it is negatively charged. So it will get one negative sign. For example, you also have oxygen. So it will gain two electrons. So it will have charges of minus two. Now, if I have to categorize them, because they have lost electron, they have got positive charges. So they are metals, right? So here they have lost the electrons, so they are non-metals. Now you know that we have also mentioned a new element type, which is metalloid. So let's us define what are metalloids. Basically, metalloids are kinds where they draw a line. They are kind of a line between metals and non-metals. So now they are kind of a line between metals and non-metals. They will have properties of both. They contain properties of both. They contain properties of both. What can be the possible properties? Of course, this is not only the properties of losing or gaining electron, but also they have many other properties. So if we link them, metalloids show the similar properties like metals and also like non-metals. Okay, so they are containing both properties of metalloids, metals and non-metals. In their example, you have boron, you have silicon, you have germanium, you have adestine, you have antimony, and you have polonium. So this is a kind of a line. Okay, now next question is where you find the question is where you find metals, non-metals, and metalloids in periodic table. Okay, for example, if somebody gives you the task of finding these elements in periodic tables, where you will find them. Okay, now this is a very simple task. Okay, in periodic table, in the modern periodic table, as you know that the category of transition elements and normal elements has been eliminated, and we are simply grouping them from 1 to 18. So if you compare them from 1 to 18, so 1 2 and then first 10, so it's almost from 1 to 12. Okay, so 1 2 to 12, almost it is going to 12, and they are all metal. These are metals. First two groups are simple normal elements, and then 10 groups are transition elements, right? After that, you have boron family, and these are metalloids. Okay, so this is a kind of a line. Okay, why they have, as you have seen that we said they have the properties of both metals and non-metals. So you can say because it is a kind of a transition between metals and non-metals, it's a line where, metals will be totally separated from non-metals. So they have properties, they have a mixed property of metals and non-metals. They are also called semi-metals. Okay, so now after that, from the group, from onwards, from if you see from the nitrogen family, from carbon family, from carbon, nitrogen, oxygen, fluorine, and then helium, all of these families are non-metals, right? These families are considered as non-metals. So you can say that from 13 is a group where of course it's been divided. So 14, 15, 16, 17, 18, all of them are now non-metals. Okay, now you have identified that where in periodic table you can find out that where are metals, where are non-metals, and where are metalloids, right?
This is the picture of a periodic table where there is a marking. All the red are non-metals, green are metals, and then purple are semi-metals. Now you can clarify that this is the marking of yellow are also that they are radioactive elements, and mostly they have the properties of metal like properties, but yes, they are not non-metals. They are radioactive unstable elements, right? So now you can clearly see that one, there is an exception of hydrogen which is present on the groups of metal, but still it is a non-metal, right? It cannot lose electron because it has only one electron in its valence shell. So mostly it is in non-metals category, and but because its atomic number is 1, so it is placed in group 1. Okay,